All right, so we were just talking about motion and then we talked about speed. Now let's talk about velocity. So, velocity is speed, but in a particular direction, right? So, remember that because you may see that again. Remember that speed is how fast you get from point A to point B. Velocity is basically the same thing, but moving in a certain direction. So, speed and direction of motion. The example that you have here is a storm moving 25 kilometers per hour. But the important part here, remember, if I would have just said a storm moving 25 kilometers per hour, that would be speed. But because I mentioned this part right here, eastward or no eastward direction, that then becomes velocity, right? So very similar. Can you have two objects that have the same speed but have different velocities? If so, how, why, or why not? And this GIF that I included right here actually shows you the answer. You see, this actually looks hectic, right? This is almost like Austin traffic, but you see people moving in all kinds of directions. And so the answer is yeah, you can have the same speed but different velocities. If you have two cars traveling at 55 kilometers per hour, but they're coming in opposite directions, then yeah, they have the same speed but different velocities, right? And so again, this GIF right here that you see, tons of people moving, probably at the same speed and definitely in different directions. Right, so changing velocity. Name two ways in which objects can change velocity. So it can change velocity by slowing down or speeding up, or it can also change velocity by the direction in which an object is moving, and then it changes. Right, those are ways that it can change velocity. And so when you calculate velocity, the good news is that it's pretty much just like speed, only you're going to add a direction to it, right? So the formula is the same. Remember, we talked about speed equals distance divided by time, and it makes sense, right? It's just how much distance you travel in a certain amount of time. So again, it's like a sentence, but it's broken down into just three simple variables, right? Speed, distance, and time. And so again, it's speed equals distance divided by time, or if we're talking about velocity, it equals distance divided by time, but you also give a direction, right? So we'll see that right now in a second. So let's try out this example right here. Find the velocity of a truck that travels 75 kilometers north in 2.5 hours, right? So basically, this is just like our speed problem, except here they are giving you this right here. And they actually put it in that orange color, and I'll just highlight it again. They're giving you the direction, right? So again, pretty much just like speed, like it shows you right here, distance divided by time. And we see that the distance here is 75 kilometers. So this is going to be on top, right? This is a numerator. And here the denominator, the one on the bottom, is 2.5 hours. So you see again, the distance, 75 kilometers, is on top. 2.5 hours is on bottom, right? And again, the top is called the numerator. The bottom here is called the denominator. Right. And then when you put those in there, it's just division. Whenever you all see a fraction, fractions are basically just division, right? You just divide the top number by the bottom number. And in this case, you're seeing that 75 kilometers divided by 2.5 hours is 30 kilometers per hour, right? But that would be speed. That would not be the answer for velocity. This would be incomplete for velocity unless you add this right here, all caps, exclamation point, and I even underlined it here twice, north, right? You got to give a direction if it's velocity. So 30 kilometers per hour north, or you could say 30 kilometers per hour in a northward direction, or 30 kilometers per hour northward, right? You have to make sure to give that direction.